All right, we're going to look at adding whole numbers and mixed numbers and fractions and all kinds of things. So if we want to add these mixed numbers of 1 and 1/4 and 1 and 2/4, and we look at adding those. Now, one thing that you can do when you draw them out, they look like this, right? We've got 1 whole part and 1/4 for 1 and 2/4. So we'd have 1 whole part and 2/4. Well, obviously, we would have two whole parts, and that's here and here, and then we have 1, 2, 3/4 left over. So that's kind of an easy way to do it, especially if you have common denominators here already, right? You just add the first numbers and then go right across the top, right? Essentially what we did was 1 plus 1, and then we did 1 plus 2/4. That's how we got 2 and 3/4. And that's a nice way of doing this. Now, to be honest, that's not the way that I do it most of the time, but that's probably even easier than how I do it most of the time. I actually usually like to do it this way, where we convert both of them into improper fractions. An improper fraction, you might recall, has a numerator that's bigger than the denominator. I'm just going to change both of these into fractions, no mixed number, and then ultimately all I'm going to do is take 5/4 plus 6/4 makes 11/4. That's usually how I do it. Then what you could do is you could say how many times does 4 go into 11? 4 goes into 11 2 times with 3 left over. So we would say 2 and 3/4, because remember that the remainder is the top part of your fraction. Okay, so you can do either one of those. Here's another one, and this just shows the way that I just did it there. Okay, are they equivalent? Yes. The difference, well, one of them we turned them into improper fractions. The other one we just added the mixed numbers. Does it matter which technique you use? Not really. They're both fine. I think they're both great. It just depends. Depends on the situation. And the more practice you get with these, the more easily you'll be able to decide which is appropriate for which situation. Usually if you have smaller numbers, smaller denominators, or smaller whole parts, then I like to just add get common denominators and use improper fractions. But when you have larger mixed numbers or large denominators, then maybe keeping them as mixed numbers might be a little bit easier. Okay, let's do just a couple examples. Use our fraction bars, the number line, fraction circles, anything you want to give you a model for what's happening here. If we want to add the sum of 1 and 1/5 and 2 and 3/5. So we'll go ahead and we'll do one of these with a model, and after that, I don't know if we'll do many more models after that. Okay, so I know we're going to need a lot. These should all be roughly the same size. Okay, and then I'm going to put these up here now. I already know how many I need. Again, they should be all the same size. I probably should have copied and pasted. So I've got denominators of fifths. Right? There we go. There's fifths, right? Go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so 1 and 1/5 would look something like this, where we've got this whole one colored in and one more fifth. And if I want to do 2 and 3/5, okay, well, here's 1, 2, and 3/5. So 2 and 3/5 looks like that. Now if I want to add these, I've got to get these on here. 1, 2, 3, 4. There we go. Remember, 4 lines here is going to make 5 parts. So you hear me counting to 4 and you're like, I thought he was doing fifths. Yeah, but I broke these up into 5 parts. Okay, so if I start doing this, I'm going to put a whole one here. All right, and then we've got 1 extra part. And then I've got 2 more whole ones here. So 2 more wholes. There's 1, there's 2. And I've got 1, 2, 3 more parts. 1, 2, 3 more parts. So ultimately what ends up happening here is I can see I have 1, 2, 3 wholes and 4 fifths left over. 3 and 4 fifths. The other way that you could do this, of course, would be to go ahead and convert them all into fifths. This one would be 6 fifths. This one would be 13 fifths. And if we add 6 fifths plus 13 fifths, that's going to get me 19 fifths. Of course, 5 goes into 19 3 whole times with 4 left over. Okay? And that's that. Let's do another one down here. Okay. I'm probably going to skip the model this time. Let's go through and talk about, and of course you could make the model just like what we've been doing, but I'm going to go through and you can see that in the printed notes. 2 1/3 and 3 2/3. Well, 2 1/3, 3 2/3. This much becomes 5, and this much becomes 3/3. How much is 3/3 worth, though? That's worth a whole, right? If we were to go through and make our models, what we end up getting then is a whole. So this actually comes out to be just 6. So I don't care if you do it like that, or remember we can change this into an improper fraction. 3 times 2 is 6, plus 1 makes 7/3. 3 times 3 is 9, plus 2 makes 11/3. And we add those up and get 18/3. Of course 3 goes into 18 6 whole times. So we still end up with 6 no matter which way you go about it. Okay. Now, I told you that a lot of times whenever I have smaller numbers, smaller mixed numbers, or smaller denominators, I like to just change everything to improper fractions. So that's what I'm going to do. Again, you can use models. You can make your rectangles in here. I'm just going to, I know you've done a lot with modeling in the past, but I'm just going to go ahead and change these. So I've got 4 times 1 plus 3, right? 4 times 1 plus 3 makes 7/4. And up here I'm going to do 2 times 2 is 4 plus 1. That's 5/2. That's ultimately what I want to do here, is I want to add 7/4. Oh, I guess I could leave it there, first number, and then 5/2. Now I need to change these so that I get common denominators. So this one, between 4 and 2, hopefully you've done enough of these, the LCD is going to be 4. So nothing changes on this first one, right? It's just like times 1, times 1. And on the second one, we're going to take it times 2, times 2. That will get me 10/4. So what I've got now is 7/4 plus 10/4 makes 17/4. Now 17/4 is a perfectly valid answer. I like 17/4. I do a lot with improper fractions. But sometimes you might run across a time whenever it makes more sense to have a mixed number. Actually, a lot of times in practicality, in real life, mixed numbers are more appropriate. It just gives us a better idea. Like if you're talking about how large something is, if you were to say it's 75 inches, well, that tells people one thing. But if you were to say oh, it's 6 feet 3 inches, usually that gives people a little better idea. So a mixed number is often more preferable in real life scenarios. You, of course, could go through and divide this. 4 goes into 17 4 whole times with 1 left over. Okay, either one of those is fine. The sum of 2 1/2 and 2/3. First thing I'll do is I'll multiply. 2 times 2 is 4, plus 1 makes 5. I just changed that mixed number to an improper fraction. Of course, this other one is just 2/3. We've done plenty of these. Common denominator between 2 and 3 is 6. So we're going to multiply this one times 3 on bottom and top to get 6. And that, of course, will be 15/6. And this one we're going to take times 2 on bottom and top to get our 4/6. So now I can take 15/6 plus 4/6 makes 19/6, which is 3 1/6. 6 divides into 19 3 whole times with 1 left over. Okay, so if we were talking about maybe summarizing this, you might say that the way that we've been doing it is to change mixed numbers into improper fractions. Then we're going to get a common denominator. After we get our common denominator, the next thing we're going to do is we're going to add the tops, add the numerators. Remember, numerator, or the tops. And keep denominator the same. Lastly, as is the case with almost any math problem that we do, is you always try to simplify at the end. Simplify if possible. All right. So that's all we do, right? Let's go ahead and look at a few others now. Okay. So here we go. Sometimes it's better to add the mixed number parts. If you look here, look at this. These mixed numbers are huge. That's going to be really large if we wanted to try to do this by changing everything to improper fractions. So this is a case where, you know what, I'm going to take this 13 and the 26 and I'm just going to add those separately. I'm going to take 13 plus 26 separately to get 39. That's the whole number part. And then what I got to do over here is take 5/7 plus 4/7. Ooh, fortunately, look at this, we've already got common denominators. This is great. I love doing problems like this. This is fantastic because this comes out to just be, let's see, same denominator, keep the denominator the same. That's 9/7. Now, the downside to this is you cannot just write this as 13 and 9/7. That's no good. 9/7 is an improper fraction. You don't want to combine improper fractions with mixed numbers. It's just not right. 9/7 though, that becomes 1. 7 goes into 9 one whole time with 2 left over. So if I take 39, which I got over here with the 13 and the 26, and I add 1 and 2/7, what I get is 40 and 2/7. Of course, you could have done this with an improper fraction. You would have gotten 282 sevenths. So 282 sevenths. Like, that's just kind of ugly. That doesn't really tell you a whole lot. So sometimes mixed numbers are more appropriate. Okay. One like this, you could do it either way. I'm good either way on a problem like this. If you want to go through and add your 6 and 5 and make 11, and add your 1/2 and 2/3, oh, got to get common denominators, right? So let's see here, 1/2, 2/3. So I know that these are going to be sixths, right? We've done that a lot. So I'm going to take this one times 3 on top, and that will get me 3/6. And I'll take this one times 2 on bottom, and that will get me 4/6. So 1/2 becomes 3/6. 2/3 becomes 4/6. And now I've got to add 3/6 plus 4/6 makes 7/6. 6 goes into this one whole time with 1 left over. So my last little bit then is to take this 11 that I already got. And I'll say 11 plus 1 and 1/6 makes 12 and 1/6. Now, that's a perfectly good way of doing this. It's not wrong at all if you're like, you know what, I just like improper fractions. 2 times 6 is 12, plus 1 makes 13. 3 times 5 makes 15, plus 2 makes 17. Whoops. Sorry, it's 13 halves. There we go. And then, of course, you'd have to get common denominators. And you would say, like, you know, let's take this one times 3. And we'll take this other one times 2. That's what's going to get us our sixths. Try saying that. Sixths. Sixths. It's 39 sixths plus 34 sixths. Well, you're going to notice it now every time I say sixths, aren't you? Okay, so then I just end up getting 73 sixths. Both of these are right. 73 sixths or 12 and 1/6. They're both good. I like them both. Great time to pause and go ahead and try to do these. Okay, just give them a shot, give them your best shot, and go from there. All right. Okay, hopefully you pause. A lot of you probably didn't. You say, I'm not going to, why am I going to pause this? I'm going to let you do this. I'm just going to copy it. You know, just copying isn't gonna help you. You should challenge yourself right now and try it. See where you go wrong, and then that way you can watch me do it and figure out where you went wrong. Now I'm going to solve these by using improper fractions. So what I'm going to do is take 7 times 6 is 42, plus 5 makes 47 sixths. Down here, for the other fraction, I'm going to take 2 times 15, which is 30, plus 13 makes 43 fifteenths. The next thing I'm going to look at is getting a common denominator between 6 and 15. A little bit of work tells me that it's going to be 30. So that means I need to get 30ths out of both of these. Okay, so that what I'm going to do is take this one times 2, so that'll be 86 30ths, and I'll take this one times 5, and that's going to get me, let's see, 35, 235. 235 30ths plus 86 30ths. Add those together, 235 and 86. When we combine them together, that's going to make, let's see, 1, 2, 3, 321 30ths. And then again with my trick with 3's, because these add up to something divisible by 3, it means the whole thing is divisible by 3. Right, so I know 3 goes into this, 3 goes into that 107, and 3 goes into the other one 10 times. So this is 107 tenths, or 10 and 7 tenths. Either one is totally fine with me. Good rule of thumb, real life problems, mixed numbers appropriate, or if the problem starts in a mixed number, maybe a mixed number is most appropriate. In this case, though, I do want to point one thing out. Our directions just say, write your answer as mixed number or improper fraction. That means it's totally on you what you want to do. That's it. Okay, so this last one then, we could do this all at once, but look right here. 3 and 2, this 2 right here, I could actually just put those together right now. I could put the whole parts of this together. I could say that's 5 and 3/5. I just do this part, and now I have 7/10. So 5 times 5 is 25, plus 3 makes 28/5. And this is still 7/10, of course. Now I got to get common denominators between 10 and 5. And of course that's going to be tenths. Hopefully you guys can spot that okay. So I'll take this one times 2 on bottom and top. That's 56/10. And look, this one doesn't need to do anything. It's already in tenths. It's 7/10. When I add those up, 56/10 plus 7/10, that's going to make 63/10. Go. You could also, if you divide 10 into that, that goes 6 whole times with 3 left over. So either one of those are appropriate. They're both correct. All right, last little problem here. The pastry chef is going to make some blueberry cake, and it requires 1.5 cups of flour for the streusel topping. That's my favorite. And 1.25 cups of flour for the cake. How much flour in total does the chef need? Well, when we see how much total flour, that means we're going to be totaling this up. We're going to be adding 1 1/2 plus 1 1/4. And I think we actually did this exact problem with these numbers earlier. But I could take 1 and 1, and that's going to make 2. And then I can do the 1/2 plus 1/4, and that's going to be 2/4 plus 1/4, right? Because we have to get this to have common denominators, right? It's going to be fourths. So we multiply this one by 2, top and bottom. And so this part then 2/4 plus 1/4 makes 3/4, and then we had the 2 whole out front. So 2 and 3/4. Now this is one where it makes way more sense to talk about this in terms of a mixed number. Because if you tell the chef, well, let's see here, let's add 1 1/2 plus 1 1/4, that's going to be 3/2 plus 5/4. Okay, so let's get our common denominator down, and we'll get this there and there, and I get 6/4 plus 5/4 makes, and you tell the chef you need 11/4. Now that could make perfect sense to the chef, because he knows, oh, if I need 11/4, I just have to get my 1/4 cup out, and I'm going to fill it up 11 times. But that seems like a lot of work. So this answer down here makes way more sense to the chef. Oh, 2 3/4? Yeah, I'll get my 2 whole cups, and then I can get 1/2 and 1/4. Or, maybe you have another one. Maybe you have a big cup and it's got a line on it for 3/4. All right, well, I hope you're able to work with some fractions a little bit easier. Hope these examples made sense to you. Good luck as you work through your addition of fractions.